Hi, everyone, and thanks for joining us today for a discussion on big data. As questions come to you during this webinar, please put them in the chat, and at the end of this webinar, we'll go through those questions. So this panel discussion we're about to have, it all started with a series of conversations that I had with each of the companies on our panel. The more I spoke to our panelists about big data, the more I realized how much the big data landscape has changed in the last few years. We have 5 very smart panelists joining us today from Replica, CityData.ai, AirSage, Kittleson, and Cat Labs. My name's Stephen Hollenkamp. I'm Director of Business Development for Quality Counts. We are a nationwide data collection firm with 12 offices spanning the country. Panelists, thank you for joining us today, and please introduce yourself. We'll go one by one. Give a background on yourself to the attendees here, a background on your organization as it relates to big data. We have a lot to cover over the next hour, so please keep introductions to under a minute. And Nick, why don't you start us off, and then we'll go Apu, Michael, Robert, and Jorge. Okay, it looks like I need to unmute the panelists. Okay, Nick, can you go ahead and try speaking?
Yeah, can you hear me okay?
Yeah, I can. Okay, thanks.
Perfect. Yeah, hey everybody. My name is Nick Bowden. I'm one of the founders of Replica. My background is in urban planning and travel modeling, but a really brief bio on Replica. We're a company that's about 6 years old. We started inside of Google and then subsequently spun out to a standalone company about 3 years ago. And we view kind of our role in this world is trying to be a provider of kind of all things about the built environment. So call it mobility data, land use data, economic activity, people, data about people and households, in an effort to provide mostly public sector, typically state DOTs, MPOs, and cities, with better information about how people are moving, how people use the spaces in their city that ideally, like a lot of companies, probably lead to better policy outcomes and better kind of physical investments. So that's a bit about us.
All right, Apu, you're next. Apu, you should be unmuted unless there's more, appears to be muted still. Okay. If anyone else would like to, Michael, I think you're unmuted.
Yeah, sure. Hi, my name is Michael Pack. I'm the director of the CAT Laboratory at the University of Maryland. My background's in systems engineering, computer science, and electrical engineering. I've previously worked at the Oak Ridge National Laboratory and the University of Virginia. But my CAT lab focuses on trying to make data more easily accessible and understandable by engineers and the public alike. Data accessibility is our goal.
All right, Jorge.
Hello, everybody. Jorge Barrios, a plant engineer with Kittleson Associates. I am based out of Orlando, but Kittleson's headquarters is in Portland, and we do have offices throughout the country. We're a transportation engineering and planning consulting company and work for a variety of different clients, including state DOTs, counties, cities, MPOs, as well as private organizations that may be developing projects and are in need of traffic impact studies. Like I said, my specialty is in data analytics and visualization, and I'm hoping to speak a little bit more about our recent experience with connected vehicle data.
Okay, Robert.
Hey, good afternoon, everybody. Robert Kohler here with AirSage. I'm the Director of Client Solutions. My background is that I'm a transportation planner. I was in consulting for about 16 years and then made the decision to get into the data and software application side of things. So I've done that for about 5 or 6 years. I've got the boots on the ground understanding of what transportation planners and engineers are trying to do. And what we do is at AirSage, we are more advisory. We figure out and scope the best data set. We've been doing this since 2000. We pioneered the market with devices, carrier data. And in about 2012, we began leveraging connected vehicle data as well. So one of the early adopters with that. 2017, we made the conscious decision to go to LBS data. Many reasons, mostly the level of accuracy. We can put people in a building now as opposed to simply what neighborhood or city they located in. So what we do is we figure out what type of mobility data insights our clients are looking for. It varies all the time. Originally, it was mainly travel demand modeling, who were our main clients we were working with, origin destinations, their travel demand model. Now we do a lot of things on safety. We've worked with OTs for putting people, vehicles rather, into HOV lanes versus general purpose lanes, looking at the speed differentials, travel times, looking at the impact of automated speed enforcement. Does it work? People only slow down as they approach the speed camera and then accelerate back after it. What was the actual adoption rate of that device, and a lot more. So we have different DOTs and consultants using our data, look at travel patterns, trip paths, actual routes that people take. That's the
Sounds good, Napu. It looks like we got you connected. Welcome.
Hey, Stephen, can you hear me now?
Yeah, we can.
Fantastic. Hi, hello, everyone. My name is Apurva Kumar. I am the founder and CEO of CityData.ai. So CityData provides mobility intelligence in the form of mobility big data and machine learning. Our focus is local government, cities, counties, and MSAs. We are focused on collecting, curating, computing, and operationalizing mobility big data for our government and enterprise customers. And we provide high quality data sets, things like origin destination matrices, trips with route trajectories, travel time, mode, speed. And we're also focused on simulating regional scale movement using agent-based modeling to meet some of the new demand and the increasing demand for scenario planning. And one of the things we've done lately, in addition to the big data insights, we are developing and publishing mobile apps and tools for local government agencies. So these would be mid to small cities, as well as larger cities now, to engage with their local communities. And we're also publishing tools for channel partners to manage their field projects like traffic surveys and counting surveys. So really, really glad to be here on this panel and looking forward to an awesome discussion. Back to you, Stephen.
All right, wonderful. Well, thank you guys. So we're going to start with sort of just an overview on big data. We'll have some of our panelists explain big data, what it is, LBS data, CV data, and then we're going to get into the bigger, broader questions. So first, Jorge, to get us started, can you tell us what is big data? What are the sources and what is it used for?
Yeah, that's a great question. Been hearing it for a long time as well from people in the industry, and I don't think that there's a single definition that is widely accepted. And in fact, what counts as big data in the transportation industry, if you go out to the tech industry, might not be big at all, right? Like compared to the data sets that the Googles and Facebooks of the world are ingesting, we don't get close to that. But what we've come to interpret big data in the transportation industry is any data source that is kind of crowdsourced, generated from a bunch of different individual sources in a way that you get really comprehensive data sets that cover entire regions or even entire countries and are too big for Excel to open. I think that's a kind of a rule of thumb in the industry. If Excel can't open it, we'll call it big data. In terms of the sources, like I said, it might be crowdsourced from cell phones, from apps, more recently from connected vehicles, anything that is generated on a point-by-point basis and then aggregated into a single data set. That is a pretty common characteristic. Second question, what is it used for? That's where we do a lot of the work here at Kittleson, making sure that our clients understand the different possibilities in applying big data to answer their questions. So for a long time, the biggest question that got answered with big data was travel times. So knowing how long it took to go from point A to point B. Pre-big data, that usually involved having GPS-equipped floating car runs, and that got pretty expensive. You would only get a few segments at a time. With the advent of big data, we were able to do that much more efficiently. It then evolved where we were able to start getting origin destination analysis from big data as opposed to license plate readers or even Bluetooth readers, and that was a big source of work for us. Lots of questions from our clients on origin destination patterns, kind of adding an additional layer of insights to the projects that we do. And nowadays, with connected vehicle data, we can get really into the weeds of traffic operations at the intersection or even street level, and speak on queues and delays, on much more detailed phenomenon. So yeah, there's quite a big range of applications for this kind of data, and yeah, a big part of our job is helping our clients sort through all of that.
Great overview, Jorge. Would anybody else like to add anything? Okay, then next. So we've already heard about LBS and CV data. Michael, can you give us a 30-second synopsis on what the difference is between LBS data and CV data?
Yeah, so connected vehicle, CV data, that's data that's coming directly from an automobile. So if the automobile has a nav system in it, and it usually also has some sort of a Wi-Fi enabled thing in the vehicle that can transmit data back to a third party. That data might go back directly to the OEM, the vehicle manufacturer, or it might go to a third party aggregator or something like that. It could be data about the location of the vehicle, the speed of the vehicle. It could be whether or not traction control has been engaged in the vehicle, or heavy braking event, wiper use, whether seat belts buckled, anything that's happening in the vehicle, including the location and speed of it. Location-based services data, you could argue that connected vehicle data is a subset of location-based services, but most people think of location-based services data as data that comes off of a mobile device, like a cell phone or some other mobile device, like an iPad or something like that, where you might have an application on your device, like a weather app or something like that, that is collecting your location and then sharing that with others, others being data aggregators who then can sell that data. So connected vehicles data gives you location data, but it's about the vehicle only, whereas LBS data, it's your cell phone, so it's you or the carrier of the device in a vehicle, or getting out of a vehicle and walking to a bus stop and riding a bus someplace, or getting in a plane and flying around, or just going on a walk or around a lake. So there's things you can do with location-based services you can't do with connected vehicle data, and vice versa.
Awesome. Good overview so far. Thank you guys. All right, so next, Robert and Apu, can you tell us a little bit more about connected vehicles? Michael covered quite a bit, but I think the big one is when are they realistic, or are they already realistic to use? When will they be cost effective options for agencies?
Yeah, they're definitely being used already today. We're working with at least one DOT and a consultant working on their entire territory. So it's something that is being rolled out. It has been rolled out. Again, we've been working with connected vehicle data since about 2012. You've got people that are looking at historical data, people that have a pipeline literally feeding gobs and gobs of data, which is one of the big things. Michael talked great about what exactly is it coming from. We've got telematics service providers, or TSPs. We have fleet management. We have OEMs, most importantly, that have a huge data set, all of which are not available, however. The reality being, these data sets for a DOT are often too large for them to understand the enterprise architecture that they need. We often talk to a DOT and the planning people and the engineering people, yet they don't bring their IT people into the mix until it's way too late. What AirSage and likely other folks are able to do, we can work with and manage that data. That is the important part. The value is the insight that comes from a very dirty, messy, heavy CSV. These CSVs, I can't remember who brought it up, they will crash your Excel if you try opening them in an Excel format. So these are really the things that are setting the tone of what is the important element, or what are we trying to figure out? You don't need 100% coverage of vehicles on the roadway to understand what are the trailing vehicle speeds, what are the different percentiles, where are the trips originating, going to, but most importantly, what are the different trip paths people take? We can get all of that from a very messy CSV file that AirSage is able to conflate to a roadway and show the high level insight on that.
Yeah, a few things I can add to that. Thanks, Robert. So in the US, examples would be data from automotive OEMs or vehicle manufacturers who receive this data coming in from vehicles that are connected to the cloud, that are continuously transmitting their GPS location in these high density data streams. So you might have GM and Ford in the US, and of course, Tesla collecting gobs of data every day. In the EU, most of the European automotive OEMs have such data, as well as the OEMs in Asia, the manufacturers in Asia. Then there is fleet operators, mobility operators. You might have automotive systems integrators who are collecting such data, as well as maps navigation companies who also get access to such streaming data coming back from connected cars. But most of them tend to hold their data in walled gardens, like Robert was saying. And so it comes down to companies that can get in there and help get some of this data out in a more meaningful way and help the OEMs or help the intermediaries to monetize their data sets. So is it real? Is connected vehicle data real? Yes, very much so. And I'd say the typical coverage would be somewhere from 2% to 15% of the total vehicle volume in a county or a state or in a city. So the data coverage is meaningful now, and it's growing every day, especially now with EVs and more connected cars. We expect the data coverage will only improve over time. And is it cost effective as well? Yes, I would say so. I think crowdsourced mobility data, or what is generally called LBS, tends to be a little less expensive than connected vehicle data. But as you get more connected vehicles on the road, I think things change for the better, where it's easier to source such data and work with such data.
Okay, great. Now, Nick, through a webinar that Replica put on, you spoke about how changes in privacy rules have caused a large decline in smartphone data. I think this is crucial to understanding the evolving big data landscape from the LBS side. So can you tell us what has happened to LBS data since 2019?
Yeah, good question, and I'll also comment on some of the connected vehicle stuff related to this. But I think I've shared before, and I'd say it again. I think if you would have asked a lot of folks that are in this space a couple of years ago what the trend line on just data availability would be, that there was probably an expectation that at some point, for privacy reasons, you might see something like GDPR, which is like a government-driven kind of regulatory framework, kind of at least attempt to put some boundaries on what's a bit of a wild west from a data perspective. What happened instead in the US is that by and large, Google and Apple, which I think Michael did a good job talking about this, but they tend to be the platforms where these applications sit on your phone or your iPad or a personal device. And those applications are the vehicle by which this kind of data exhaust, right, kind of flows from, but then tends to go into like third-party aggregators, which then do some cleaning and processing, then other companies end up buying it from there and doing some of the stuff that other folks have talked about. Around 2019-ish, I think Apple was the first kind of mover out of the two, started to put more stringent requirements on app developers as it pertains to their ability to collect location data for what before was they could just collect it no matter what. And so if you remember, for folks that have either an Android phone or an iPhone, it used to be the case that a lot of these apps just collected your location in the background all of the time, even if the app itself didn't have any kind of location component. So any number of apps would just be constantly collecting kind of location data. And a lot of people didn't realize it till the battery didn't last as long. And then you go in and you have to like really make a lot of effort to actually like not allow them to collect that data. Apple brought that to the forefront. And now if you open your app or your phone and an app is collecting location data, it will give you like very specific prompts, which is one, do you even want them collecting data? And if you do you want them to do it just one time? Do you want it to only do it while you're using the app? And there's not even an option anymore, with rare exception, to just like passively collect in the background for no reason. And if they have that, you've actually got to re-up effectively the approval process. I think depends on the app, but between every 14 and 30 days. And so what effectively happened was pre-2019, 2020, if you went to buy like device level data, so Michael distinguished, and I think he's right, like, LBS data is probably or connected vehicle data is probably a subset of LBS data, but in the context of like handheld devices. If you went to try to find some of that data, it was widely available and very, very detailed and had very large sample sizes. Subsequently, since these privacy kind of controls have gone into place, that sample size, on the whole, you might be able to get like the same across a bunch of different vendors, the same number of devices, but below the surface, the location pings per device, which is a really important kind of component of quality, and the dwell time, meaning how often you see that device in a given day or a given week or a given month, have plummeted. And they tend to be inverse related, meaning the more devices you see in a sample, the more likely it is that those devices have lower pings per device and lower dwell time. Why does that all matter in the context of this conversation? Regardless of the technical method that you're using, whether you're using like a modeling based approach or an aggregation based approach, you generally want to see the same device kind of over and over and over again, because it gives you insight into the kind of the behavior of that device. And so connected vehicles are really great for this because they're kind of always on and you get precise location data. The challenge or the trade-off with connected vehicle data is, obviously, as the name indicates, it's biased towards private vehicles or private autos, which means you're not capturing a part of the world which is transit riders or walking and biking or kind of other elements. And so I think the shift has created a decent amount of volatility in this space, frankly. I know a lot of folks kind of had shifted into like heavy handheld device kind of utilization because it was really, really granular. It was outside of the vehicle. You could capture more things than just kind of mobility patterns. I think there's been a bit of a retreat back to kind of connected vehicle data, not just because it's available, but because I think the comment I was going to make is, I don't know if anyone said this, but a lot of this new connected vehicle data is not just really good like movement data. It also includes things like, are the seat belts clicked? Is there water in the wheel well? Are the windshield wipers on? Are there passengers in the back seat? There's a bunch of other kind of elements that have really interesting kind of safety implications of being able to measure safety stuff. Hard braking is an example of this kind of stuff, distracted driving. And so there's a new set of like, I'd refer to it as like, I don't know, a breadth of data tied to connected vehicle data that gives you more insight into the behavior kind of within and around the car, not just the trajectories. And so there's a lot of like really interesting things happening kind of in the space as it pertains to like the most upstream version of the data that most of the companies that you might interact with utilize.
Okay, great. Would any of the other panelists like to weigh in or add their perspective on this?
So on AirSage's end, I'll add that we've seen roughly the same number of devices. Again, we've been doing this for over 20 years. So it's really also about, do you know where to find the devices that are worthwhile to leverage? We don't leverage 100% of the data points in our data panel. So then it's quality of the device. Is it highly visible, highly active? Does it move around? Is the device on all the time, pinging all the time, but never going anywhere? Is it inside an apartment building that never leaves? So these are the things that on our end, we need to make sure we see, because correct, there are noticeable decreases in the number of pings per day on average. But from the outset, there were also a lot of devices that didn't ping much. So it's really trying to figure out which devices should be leveraged for any of the insights anybody wants to get post 2019, pre 2019 is less relevant on our end.
Okay, great. Thanks, Robert. Thanks, Nick. Okay, now we're going to go to some broader questions. With that foundation of big data is a hot topic, but can sometimes feel abstract to people. Panelists, can you please describe how your firms use big data to address challenges faced by cities and travelers? And we can start with whoever's pulling up this. Yeah, we'll start with you, Jorge.
Sure. Yeah, and like I said, this is kind of our bread and butter, helping our clients extract value out of these big technical data sets, the big CSVs with obscure column names. And the way we like to frame our work is really to first make sure that we understand what the questions are that need to be answered. To us, the best analytics is not the most sophisticated or the one that uses the most machine learning, but rather the one that answers the questions that really matter. So we are pretty careful and thorough in working with our clients, our stakeholders, to make sure that at the very beginning we know what those questions are. We know that what the decision points need to be, so that when we go out and seek a data set or seek an analysis methodology to apply, it is with the purpose of answering a specific question. So, for example, one of the kind of common questions that we face is having to do with cut-through traffic. So I'm sure pretty much everybody here has experienced it, where you have a neighborhood and there's maybe a collector or a residential road that was designed for relatively little traffic and just basically people accessing the residential neighborhood, but in fact, due to the role in the network, it carries way more traffic than you would anticipate. And so those municipal clients come to us and they ask us to use big data to help them understand where this traffic is coming from and going to, and help identify other ways of serving that traffic that kind of balances the needs of that neighborhood's residents and the travelers. So that's just one example. I'll turn it over to Apurva.
Thanks, Jorge. So city data, we think of ourselves as mobility, big data plus AI, but that's a mouthful. And most mid to small cities may not even appreciate the tech behind all of this. So we try to break it down into meaningful sound bites. When we're having these conversations with local government, when we're talking to our clients, we may start to ask questions like, do you know how many people are in your city today or in your downtown core? And how is this impacting your downtown economy, your businesses in your downtown? Or how many people visit your parks and trails? And are you able to quantify equitable access to your park systems? Or it could be something very specific like the balloon festival or maybe the county fair that happened this past weekend. Do you know how many people visited and what neighborhoods did they come from and what routes did they take? How many vehicles, pedestrians, bicyclists during those events? Some of the newer topics tend to be around electrification. So maybe the city's looking to deploy EV charging stations, and we may ask about, do you know the best sites for your EV? And would you use some real data for that? Or are you planning to use federal infrastructure grants Safe Streets grants and other programs that you could use some real LBS data for. So these types of questions, it makes it a lot easier for our clients to understand the value that location-based data, crowdsourced mobility data, or connected vehicle data brings, big data in general. They typically have these use cases in mind, but these questions help them to crystallize their thinking, and it becomes less abstract about what they can do with all this big data. Back to you, Stephen.
And then on AirSage's end, we do a lot with origin destination trip matrices. That's probably the biggest element that we get into. So we work with MPOs and the consultants working on their behalf, whether they're creating a new travel demand model, updating an existing one, looking to validate, calibrate, or do any of those types of things. Those are one of the biggest elements we have with our big data. So they're the end user actually pulling the knobs and levers in that model to figure out what works, what doesn't work, and to benchmark their output for an existing condition. Additionally, on top of that, we're working a lot now with the connected vehicle data on before, during, and after studies. We can call it before, during, and after a construction project. How did trip paths and routes that people took change? We can take a look at before automated speed enforcement was installed, what's going on that roadway segment. We can look at HOV lane or any type of segregated facility from general purpose lanes. How does that change? Things like that change by time of day, day of week, and seasonally. So we can't just look at one thing in unison, and big data really lets us help our clients by looking at a multitude of days in a very safe form. I've worked on hundreds, if not thousands, of traffic studies. You don't have to be out in the field 365 days to get the data to understand what are the travel conditions, how are they changing, what do people in aggregate do? So that's really how we're helping out.
Okay, Nick or Michael?
Yeah, sure. So we take we at the Cat Lab take data from these connected vehicle sources and different location-based services aggregators, and we try to merge that data with weather data and with agency created data like incident safety data or vehicle counts, volume sensors, and other types of data that the agencies collect. And we try to bring that together to try to paint a picture of what's going on the roadway. So if there's a crash that occurs on the roadway that's blocking all the lanes, you can then see how are people detouring around that incident in real time. Are they taking the routes that you want them to take? Are they taking a different route? How can you use that to inform your operation strategies and your planning, especially if you've got a bunch of commercial vehicles that are taking routes you don't want them to take? Or if we are getting really high frequency pings from a particular connected vehicle, maybe every 2 to 5 seconds, then we can use that location data to actually understand how people are interacting with traffic signals. So what are the cues like at a particular traffic signal? How many people are turning right, left, or going straight? How many are arriving on green, on red? Are there any control delay or split failures? There's all sorts of signal performance measures you can derive from this data. And during the pandemic, we were also using these data to understand mobility, changes in mobility. How many people were actually staying at home? And if people weren't staying at home in a particular city or state or county, were they going to work? Were they going on pleasure trips? Were they going to the grocery? And could we use the data to understand if people were potentially importing cases of COVID back from high-risk locations into their hometown? There are all sorts of possibilities.
Okay, Nick, would you like to add anything?
Yeah, just we do a lot of what other folks mentioned, but maybe something that is a little bit different is we there's a lot of use cases I'll give an example of one we're looking at now that we're working with some federal agencies on that involve things that are mobility and something else. And so take a safety use case, which might be, do you see more hard braking or distracted driving in a bar district, and how much of that is related to how many people are in a bar district at a certain time of day might be an example. And so for that particular use case, you might look at economic activity data, which is the amount of money that's being spent in a given area and the variance between that for a given week or a given month, and then look at associated travel behaviors around that bar district at a specific time, and then also look at things like hard braking or distracted driving or accelerated speeding. And the point there being, like, can you actually identify cause and effect? Like, it might sound obvious, right, that after at 2 a.m. in a college bar district that you're going to see an increase in things like distracted driving or an accelerated, high amounts of acceleration, but to actually be able to prove those kinds of things out empirically and say, it turns out that this is the relationship between these kinds of things. And so oftentimes some of the differentiated use cases that we end up getting involved in are because we've got everything from parcel level land use to building use to spending to demographics to mobility. And so it's like mobility is a key part of that, but it's a key part in the context of other things that are happening in a given environment. So that may be a slightly different kind of policy level use case that we end up spending a decent amount of time in.
Okay. Next, what is the biggest misconceptions agencies have about big data?
I'm happy to chime in here as a starting point. I think big data, whether it be a sample or whether someone models it up, is never 100% real time purview into the world, right? It's maybe how I would describe it. And so by definition, it's not gonna fit perfectly to like what's actually happening right now, right? There are versions of that, right? So you have like real-time traffic, but even real-time traffic, right, as an example that a product a lot of companies offer, you don't actually need to see every single vehicle. You just need to see a minimum viable number of vehicles in a certain kind of network congestion to be able to say things like, this is clearly congested, there's too many vehicles based on the capacity of a given roadway at a given time. I think a lot of agencies sometimes have the expectation that they've done a traffic count once, and so therefore if they buy big data and that big data provider has some set of traffic counts, and it's going to perfectly match the one time they did a traffic count. Or they've done a bike and ped count once, so they have a counter, and that therefore big data will match that. But I actually think something that we often talk about is like, you actually want both of those things. Like you want, there are times when you actually want to do a specific count at a specific location for a specific purpose. There are times when you actually want a really wide set of data that is close to, right, and has like margins of error that are usable, but they're actually not oftentimes they're not the same thing. They're two different tools, like in a toolbox. One might be a hammer and one might be a wrench. And it turns out you need a hammer and a wrench. And sometimes the job requires the hammer and sometimes it kind of requires the wrench. But I think oftentimes agencies want these things to converge into like a single thing, but they're just not a single thing. And you've got to understand that different tools can be used for kind of different purposes. And so I think there's still a decent amount of, I'll call it like just market level education. And I think, to be fair, I think vendors actually play a really, really important role in talking about the limitations of big data. And I think oftentimes the vendor industry kind of talks about all the things that are perfect about it, but doesn't mention that like it's just not good for every use case. Like I wouldn't advocate our data to be used for every single use case. In fact, there are other vendors on this call that actually might be better in different use cases than we are. And there's other options that are kind of appropriate options. And so I think actually getting people on the same kind of wavelength of understanding of like where big data is really, really good and maybe where it's limited, and where they're sometimes you want to do surveys, right? And that's like out of fashion, but that can be actually a good tool in a broader toolbox for a certain set of conditions. I think is oftentimes the misconception that we run into at a lot of agencies.
Yeah, well said. Apu, Robert, Jorge.
Yes, if everything Nick said, so the hammer and the wrench analogy is just spot on. You do need LBS, you do need big data. You also need the surveys, you need spot counts, you need the ground truth. The other thing that comes up is data coverage. And we get this question a lot about what is your data coverage? And I may say something like city data represents 64% of your city in terms of big data. And then the immediate next question that's thrown at me is, well, what about the other 36%? And so we spend a lot of time helping our clients understand how is data coverage measured and why 64, 65, 50% is not just a strong sample, but a significant sample. But I guess where this all leads to is, there's this misconception about big data, whether it is crowdsourced mobility, LBS, or connected vehicle, that such data sets and such data providers overlap with each other or compete with each other to find the best results. And from what I've seen over the past many years, the fact is no one has all the data, really. Not even a Google or an Apple would have all the data that truly represents what is happening in terms of mobility in your city or your county or your state. And so the way we see this now is big data, in our view, is a collaborative process. And so data providers must work together, pool their data sets to help cities and MSAs so you can create the best representation of mobility. So it falls on us, but it also falls on the government agencies. So they need to do their part to define this as a collaborative process. And so when they put out their RFPs and their RFIs, I think they should encourage more collaboration across the ecosystem. And we are starting to see some of this happen with the formation of transportation coalitions, but I think a lot more could happen.
Following up on that hammer and wrench example, we found too many people trying to make the wrench into a hammer and trying to make it fit when it's not appropriate. There's appropriate use cases sometimes for data, specifically big data, and then there are edge cases and completely woefully unacceptable, inadequate applications of the data. And sometimes we have people trying to do that. They've gone too far, and it's kind of like you keep whittling it down and whittling it down. You have no sample size that's statistically relevant, and you have an answer which is not reality. And, all devices, specifically mobile phones, are not all equal in value. It's understanding which ones should be leveraged. There's not a string following our mobile phones around. Your battery would be dead by about 10 o'clock in the morning. So it's really a matter of the DOTs and MPOs and other users of the data need to be cognizant of there are going to be gaps in between pings. Now in a connected vehicle, they're much more persistent pings. They happen all the time, repeatedly, 5 to 10 seconds maybe. Your mobile phone might not have every element of what the person did. So a lot more of it then is thinking we know and assuming where a person might have walked, as opposed to with a connected vehicle, we unequivocally know what route or path they took.
Then another misconception that we've bumped into when approaching our clients about using big data is that some of them feel like they need to have a highly trained set of in-house data scientists to really make use of big data, when most likely the agencies would be purchasing the data through a company like one of the ones on this call that have already built in a lot of tools and filters and aggregations. Some of them even have a kind of serve yourself website where you can go and through a graphical user interface get and analyze data so that it's in a nice little spreadsheet once you get it out of that tool, and then pretty much anybody with just basic GIS or spreadsheet skills can then take it and apply it to their project. So I feel like some more education in that regard would be good to showcase all the different tools. I think like Michael was mentioning the Redis platform and all that you can get out of that. You don't really need to have data science skills to use that. A little bit of GIS and spreadsheets would do.
You're on mute, Stephen.
Yeah, I think he muted.
Yeah, sorry guys. So what questions should agencies be asking when they're talking to LBS data providers or CV data providers to be best prepared to make effective procurement decisions?
So from an LBS data standpoint, coming from a mobile phone, the biggest element is what is the output? Are we talking person trips? Are we talking vehicle trips? To go from a mobile phone to people having vehicle trip output, there's a lot of assumptions that go into it. The number one question would be, what's your expansion process? The reality is nobody has 100% of the data out there. So we have a subset or a sample of the data. How do we build it up to represent what 100% of the environment is doing? Alternatively, it may not be even expanded. It may be the sample count that is observed. But to get between person trips or devices and connected vehicle to a line, or putting those people into a car, what's the average vehicle occupancy? You know, I've done enough planning studies by income, by age, gender, where people live, where they work. All these things matter to determine what's their propensity to take transit or carpool. So when we go from a mobile phone to a mode, more often than not, especially in an urban area, there's a lot of inferences that have to be drawn. So expansion and how we get people versus vehicle trip.
Yeah, couldn't agree more with what Robert said. So if I may add maybe one or two items to that. So yeah, expansion or trying to go from whatever your sample size may be, 64, 65% to 100% using gap fill or scale up or other types of machine learning techniques is important, and understanding what your data provider can do in that regard is critical. The other thing would be to have them explain the methodology for transforming that raw LBS big data set into the actual insights, whether they are trips and routes and trajectories, geometries, correlations with census data, correlations with transaction data, weather data, whatever those outputs might be. If your data provider can explain the methodology at a high level, maybe through a blog write-up or maybe a peer-reviewed paper, it's always helpful. And this kind of ensures that they're not selling you or giving you a black box. You need to be able to understand how they arrived at the results or the recommendations that they are making based on that big data set.
Another question that I usually ask, because a lot of our work is time series based, so usually we might be looking at a period before a project went in and comparing it to a period after the project went in. I do usually make sure that the data is comparable. So some of these data providers have different filters or methodologies, and those are changing over time. And in some cases, that makes the data not comparable against one another. And so if you're doing any sort of time series analysis, you wanna make sure you ask that question.
I'd add this is less about the data itself, but I think something that we see often is my question to agents is always like, what problem are you trying to solve? And I think oftentimes, I think a lot of agencies have this feeling almost of anxiety, like they need to start using big data and they need to use big data more. And I don't know that that's wrong, but I think there's probably less thought put into like, what is the particular problem that we're trying to like get better insight into? Is it a before and after? Is it network level? Is it like just generically having more data to answer more questions in the future? Because I think the question that you're trying to ask is probably going to yield a different set of like questions that you should then ask providers based on that particular use case. And I think sometimes agencies get stuck in like very, very generic kinds of like provider questions, which are not wrong, but the specific question might actually be different if like Jorge just mentioned, like if you're doing like network level before and after time series, then you're going to want a certain set of questions to make sure that you have consistency across time and that the providers like technical methodology didn't change or upstream vendors didn't change. Because if you're looking for what was the volume on a roadway before we did a construction project, and then we implemented something, and now we want to do something different. You want to be confident that the changes that you see in the data are actually changes because of what happened in the real world, not changes because the upstream sample changed, or changes because they changed the way that they do routing, or changes based on something else. And so I think being able to isolate those kinds of things oftentimes just depends on like what's the use of the data. And I think one of the good things and bad things about like DOTs buying a lot of data is that DOTs have a very diverse set of users. You've got like operational departments that are thinking about speeds and congestion and kind of roadway maintenance. You've got a growing number of active transportation kind of divisions of DOTs that are thinking about bike and ped. You've got safety divisions, and every one of those use cases is different, and has different sets of kind of limitations and different sets of like how they get used. And so oftentimes the procurement methods, whether you like look at an RFP or you're talking to an agency, end up being very, very top level, like 10,000 foot kinds of questions, when in reality they probably need to be asking like 1,000 foot questions to see if the data can actually support the use case they have.
Okay, very good advice and thoughts here. So if you guys have any questions, any of the attendees, please put them in the chat. I wanted to make sure we talk about Redis for a second, because I think everybody should know this. Michael, you run the Redis platform, which I did not know contains data sets that many state DOTs have already paid for and might be a free resource to some of the listeners today. Can you tell us about Redis and how attendees or agencies could potentially use Redis?
Sure. So Redis is a platform that was designed to take agency data and private sector data, bring it together, try to standardize it, fuse it, and then make it available to folks to analyze. When I say make it available, it's through web-based analytics. Redis is essentially trying to be the equivalent of like the National Weather Service, but for transportation. So National Weather Service is they provide open weather data for the entire United States so that everyone has access to weather data to make important decisions. It's important to national security and economy and everything in between. We don't have a national view of transportation data. So that's what Redis is trying to do. There's about 40 states that fund some portion of Redis. And there's a good chance that the state that you live or work in is funding something in Redis already. And if that's the case, then if you're working even as a consultant or a university researcher or an MPO, if you're working for some sort of a state or local project, you most likely could get access to some portion of Redis for free. And then you'd have access to some of the data sets that we talked about today. Of course, it depends on the part of the country you're in. But yeah, there's trips analytics tools, there's signal analytics tools, there's safety analytics tools, and environmental impact tools, before and after study tools. There's a little bit of everything in there. So feel free to reach out to support@redis.org, or you can reach out to myself as well if you are interested in learning more about it. We might be able to get you free access. Who knows?
Awesome. Thank you, Michael. Okay, so if anyone has any questions, please put them in the chat. I have another question I can ask in the meantime, because we don't have any questions so far in the chat. But guys, what future applications and uses do you all see for big data?
So right now, AirSage has begun to embark upon working with NASA and some other organizations at more of a nationwide scale to look at flight paths for drones and things like that. So it's not just based on origin destination, but also based on where population densities are. I think that's going to continue to advance as we look to either possibly go to air mobility for people or just package delivery.
Go ahead, Apu.
Yeah, that's a deep question, and I'm probably not going to give you a futuristic answer. But what we are starting to see is, so we operate on a global scale. We have clients in LATAM, we have clients in the EU, in the Middle East, in Asia, Southeast Asia, and we are starting to see big data, mobility big data, whether it's LBS, connected vehicles, combination of many different things. It's turning into the foundation for understanding how people move and how people consume services across all our cities, municipalities. So while transit and transportation is the line of sight use case, it's the obvious thing to do with such data, we think big data actually will be key for economic development, urban planning, new mobility, like Robert was saying, urban air mobility or drones, resilience, equity, safety, like Nick had a great use case about safety. So we really think this big data will touch almost all aspects and all agencies in our cities and counties in the future.
One thing I would really love to see is through integration with count data, like like the type that QC provides, those short-term 100% counts. I would love to see big data be able to produce more reliable volume estimates on kind of wide swaths of network at a time. I feel like that would be incredibly useful to our profession. And we're just not there with the current level of big data penetration.
So, as data gets bigger and bigger and more complex, to me, big data is really about the creation of underlying technologies that are enabling us to be able to process these massive data sets. So, moving away from relational databases and more to Hadoop and distributed data platforms. And I think there's lots of opportunities with these platforms that enable the analysis of big data that are going to start fusing these location-based services data and connected vehicle data sets with data sets we never ever thought were related whatsoever, that are going to bring in all these new insights, help us start to predict things and understand what might be in store for the future, and driving all sorts of insights, kind of like what the drug companies are doing today with testing new drugs without actually having any patients being tested. They're using all sorts of different data sets and artificial intelligence, machine learning to try to do that. I think some big data is pushing us more towards the realm of machine learning and artificial intelligence. That's what excites me.
Okay, so we have a question from Brian. Michael, you answered it a bit, but I'm going to ask the panel if they've got specifics. So Brian asked, do some platforms lean toward planning apps while others for ops apps? Michael, you said yes, data sets do. Do you guys know of specific applications or platforms that lean toward being better suited for planning applications versus ops?
Well, the RIS platform that I run, it has some apps that are definitely meant for operations, real-time or near real-time operations, decision support, and response to emergencies and rerouting and all that sort of stuff. But then we archive all of the data that we get, and that archive persists indefinitely and can be used for all sorts of planning decisions as well. And I think a lot of the other platforms here are great for planning decisions. But even a planning system can be used to inform operation strategies sometimes.
Okay, well, we are about out of time. So I want to thank you all for joining us. Super big thanks to our expert panels. Guys, could you put your email or contact emails in the chat? We'll be sending out webinar of this, but I realized we don't have a slide here for contacting you guys. So please put your emails in the chat so people can reach out if they'd like to. And with that, thanks everyone. Thanks for joining, and yeah, have a good day. Bye.
Thanks, Ian. Bye.
Thank you.